When you look into human brain, if you want to have these tools in hospitals, the question you have to do, the first question is, how much data we will be handling? So if a patient goes to the doctor and the doctor says, you know what, I'm gonna look into your brain, we're gonna do a test, and we're gonna see what's going on, or what's not right, what's working properly, and what needs to be treated. So that physician will be using nanorobots to properly diagnose the patient. But the first question is, how much information will we be extracting from a person's brain to properly diagnose that brain? In other words, what is the processing power of a human brain? You typically do that question when you buy a laptop. You ask, how much memory do I have? How many programs, how many files can I fit inside this computer? And also you ask, what's the processing power, right? Can I run, the Game of Thrones? Can I run Windows, right? So the same question for the brain. What's the processing power of a human brain? And when we look into the literature back in 2012, we realized that the best estimates for the processing power of human brain were really different. The lowest estimate was around 10 to the 11th bits per second, and the highest 10 to the 28th bits per second. We're talking about 17 orders of magnitude difference. That's, nobody had a clue, essentially. So what we did back then was to look into, create a new formula to estimate the processing power of the human brain, and we compiled the processing power of the different regions of the human brain and its subregions. So this table, published on a paper back in 2012, compiles the processing power of a whole human brain, as well as its regions and all of its subregions. With this tool in hand, physicians in the future will know, the type of allocation of power that we need computationally to be able to diagnose a person if we need to, for example, scan the cerebellum or the prefrontal cortex, right? So if you want to treat a patient and you know the part of the brain you want to treat, and you're extracting data, you need to know how much processing power you have over there. Looking into the brain as a whole, we came up with a very precise estimate of 5.52 plus or less 1.13 bits per times 10 to the 16 bits per second. So that's rounding it, 5 times 10 to the 16 bits per second. That's the processing power of a human brain with 1.10 to the 16, 0.1 point to 10 to the 16 margins of error. So we finally said, this is the estimate, and these are the margins of error, so it's certainly here.